Welcome back everyone to part 2 of the OrCAD X Capture tutorial series. My name is Adam Fuchs. I am a product engineer at Cadence Design Systems, and for this video, we're going to focus on creating our first libraries, specifically adding third-party parts on demand or directly to our library, as well as maybe creating some of our first parts, but we'll see, maybe we'll get to that in the next video. Now, if you've been working in your own environment, please continue to do so and follow along with the instructions in this video. If you're just joining or would like to start following along in the tutorial, you can always download the accompanying design database below and any of the files that are used in this video. All right, so before diving in headfirst to the new library authoring environment, let's quickly talk about how the OrCAD X Cloud manages our workspace. Now to do so, go into the View menu at the top of your OrCAD X screen, and then down in the Workspace section, highlight Workspace and go to Configuration. Now, as a user of the OrCAD X Cloud, you are allowed to have as many workspaces as you need. Now, every user also gets a default workspace called My Workspace, and you'll notice here that I already have one called My Workspace. And then I added another workspace called Cadence. As you're working and adding parts to your library, initially they will be added to My Workspace. And if you're working on a project with multiple users, whether it's other engineers, other librarians, you can create other workspaces and invite other members to participate in those workspaces. So here I'm looking at the Cadence workspace. I've added Alok, my coworker, and I've allowed him to act as a librarian, a designer, and an administrator in my workspace. To add a workspace, simply type in the name here and press enter, and same thing to add a user, simply type in their email that they use for the OrCAD X Cloud, and they'll be added in through here. But for these videos, we are going to work in the My Workspace environment. So the only thing we need to do in this window is just make sure that instead of the CIS data source being set to local, make sure that it is set to cloud. Other than that, everything else in the workspace configuration can be left as is, then press OK. Next, go into the View menu again. Under Workspace, select File Manager. As I mentioned before, the OrCAD X Cloud workspace basically keeps a copy of what exists in the cloud on our local machine. And by accessing the file manager, we can see the file structure of all those documents and files copied on our local machine. You can use these arrows to expand or contract any of these folders. And you'll notice that under My Workspace, there are libraries, there are projects, there's that how-to project that we created in the last video. And if we go into the symbols or footprints folders, let's go into symbols first, you'll notice that there are OLBs, which is basically symbol containers. And if I jump into footprints, there are DRAs, PSMs, pads, and other such files which are required for a footprint library. Now you may not have these yet. One thing that we're going to do in this video is actually set you up so that you have some footprints and some symbols to begin working with. First things first is go into the symbols directory, and you can actually, let's go up one directory into libraries. If you highlight the symbols folder and do a right click, select show in file browser, you can open that same folder location in the Windows file browser. We'll jump into the symbols folder, and in here we want to paste the symbols.olb that is included in this video's files. Inside of that symbols.olb is all of the symbol graphics that we will need to create the parts covered in this video series. So I happen to know that it's in my documents, go to videos, and here's symbols.olb. I've also included a symbols_all.olb. In one of the videos, we're going to create one part from scratch. And so the symbols_all.olb just has that extra part already created rather than having to create it from scratch if you don't want to. So we're going to copy that, go back into our workspace and paste it in there. So there's the symbols.olb. If I jump back into my file manager, we should see symbols.olb show up soon. I can click on this Cloud Sync icon in the top right corner of the file manager, refresh it if I need to, and this will just let me know if there's any files that are still pending to upload or download to or from the cloud. Now the other thing that I said that we need is the footprints. So if I go back, there's this how-to videos footprint lib.7zip. I'm going to copy this, and you can go ahead and if you go into the library's footprints, let's show this in the file browser, you can paste this how-to videos footprint lib.7zip and unzip it in this folder, and it will include all of these footprints and pads, the DRAs, the PSMs, and the pads as I mentioned, and any 3D files as well if needed. So I'm going to go ahead and cut this because it already exists in my environment. If you have any issues with this, please leave a comment and we'll try to help you as much as possible. But once you have both of those placed, after some time they should both be essentially uploaded to your workspace and then copied so that they're also existing inside of your local environment. Now, let's go back to our schematic. Let's first focus on how to add a part from a third-party provider. To add a part, go into the Place menu and select Component, or alternatively, there's this icon in the top right here, Place Component. This will launch the Component Explorer, which is our one-stop shop for all of the components in our libraries. As you see, here's the My Workspace, the Cadence workspace, which I created earlier, as well as SamacSys, Librarian and SnapEDA, the 3 third-party libraries which we have access to. I'm going to go into SamacSys. Let's take a look at some of the parts that are available in SamacSys. By default, we'll get some results that you can scroll through. At the top here, you can type in a search query, for example, MIC 5205, and see what parts SamacSys has that match this search string, MIC 5205. Now there's a lot of results here, and one of the best ways to filter through your results is to simply look at these last 4 columns here when looking at the different results. The first of these, if you hover over it, is called Datasheet URL. The second is Have Symbol. Third is Have Footprint. And the fourth is Have 3D Model. So what that tells me is these first about 10 results or so, most of them all have a datasheet attached to them, have a schematic symbol, have a footprint, and also have a 3D model. So if I were to download that part, I would have no problems with both placing the schematic symbol and also exporting to my PCB and having a footprint already downloaded from SamacSys. If I were to select this option here, you see that it doesn't have a datasheet and doesn't have a 3D model, or these down here do not have any of the 4. You can also click on any of these results and inspect the properties on the right side. Let me just make this a little larger. Here, if you scroll through, you can see all of the different properties that are attached to this part, as well as at the bottom here, there's the symbol and footprints carousel. You can click through and get a nice preview of the schematic symbols that are available for the part, as well as the footprint. Now, before we go adding this part to our library, let's just place it on demand into our schematic. So right-click on the result and select Place. It's going to go ahead and download the part, and then it should switch over onto our schematic page and hover under our mouse cursor, allowing us to place it anywhere we want on the schematic page. To place it, simply left-click, and you can continue placing more instances of the part, or press Escape to finish placing the part. Once the part is placed, to zoom in, either use Control and the scroll wheel to zoom in, or use the click and hold the right mouse button to draw a square or zoom by points in the area that you wish to zoom into. So this is the first part that we've placed in our schematic. Now we can select it, we can move it around by clicking and dragging, but it might not be the exact format that we want. Maybe we need more space between these pins. Maybe we actually want some more information displayed underneath the part. So here we have a reference designator as well as the part number. Maybe we need some additional information like the output voltage. So you can actually go through and create a whole design by placing parts from the third-party providers without adding them to your library. But by having a library, you can do a little better job of organizing all the parts and keeping all of the important data organized. So let's go ahead and select this part and delete it just by pressing delete on the keyboard. And let's instead add that part to our library. I'm going to go back into the Component Explorer and click on My Workspace. Now, before starting these videos, I actually deleted all of the categories in my Workspace library. So the first thing we're going to do is create a category where that MIC 5205 part can exist. To add a category, I'm going to right-click on My Workspace and select Add Category. You'll notice that a new window pops up. This is the window where we can add a new category as well as any properties that we wish to attach to that category. Let's go ahead and name it. This will be our category for ICs. These will be electrical. You can also choose mechanical if you have mechanical parts. And let's go ahead and add a description of integrated circuits. And then we can also add some properties to our category. To add a property, click on this plus in the top right corner, and we can add a name. I'll start with the height category. And let's add a couple more. For now, let's have a total of 6. I want the generic name as a category. I also want the class. I want the min temp, the max temp, as well as the package. Now, these are all up to your own preference on which categories you want to include. There is no one category that you must have necessarily. All of the required information is done through attaching certain objects to the parts. We'll see that in a second. While adding a category, you can set a default value. So for example, if I know that all of the ICs in my category will have a specific package, I could set that value here, as well as setting a description. So I can set this to generic name. This will be the part classification. Next, we also have this column for visibility on schematic, and that is whether or not we want this property to by default be visible on the schematic. I'm going to go ahead and keep these all as do not transfer. These are usually properties that I only care about seeing when I'm inspecting the bill of materials. On my schematic, for example, if I'm working with like a resistor, I would only want to see things like the value and the tolerance. Meanwhile, I might not care so much about the height of the part. Finally, we have this option for the value type, whether it's a string or numeric. We're going to keep these all as strings. And then this last column, show in place component, is basically just a checkbox of whether or not we want this property to be displayed as a column in this search results here. So if while searching through ICs, we want to see the package type, for example, we can check this show in place component, and then that will be included as a column in our search results. Now we're pretty much done here. If we were creating a category or even a subcategory, that we knew had all the same symbol type or model type, we could add a default symbol or footprint. But in this case of ICs, it's very common to have different types of footprints, different types of symbols with multiple hundreds, thousands, millions of different pinouts. So we're going to keep this empty for now. Let's go ahead and save our category. And there it is. We have now an IC category. So let's go back into SamacSys and add that part into our library under the IC category. I'm going to search again for MIC 5205. And we're going to use this first result here, MIC 5205-5.0 YM5TR. To add it to the library, do a right click, select Add to Library. It's going to download the part. And then it's going to ask us to assign a part number. I like to have internal part numbers. So in this case, I'm going to do a Control X here because I might want to use that part number later. I'm going to save this as CDN-demo-0001 as our Cadence demo 0001 part. For the lifecycle, as you start working in your library, you might want to use different life cycles for your parts, especially once you've verified them that they're correct for sure. We're going to leave this as in development for now. For the category, let's select the IC category, which we just created. And if we had any subcategories, we could select them here. For example, if we made a regulator subcategory. Now, these are the properties that are by default imported from these properties that we saw here into the part. If we scroll down, you'll notice that the properties which we defined for the IC category have also been added to this component instance. We can fill in some of these values that are specific to this part by simply double-clicking in this field. And for the generic name, I'm just going to paste that last value and use MIC 5205-5.0. For the class, I'm going to call this a IC. For the minimum temperature, I am going to just set this to -40 degrees C for now, and for max, 125 degrees C. I'm not sure if these are correct, just for the sake of this demo. For the package, I believe this is SOT 23-5. And then for the height, let's set that to 1.45 millimeters. Once all of our properties are set, we can go into the Models tab. Now this Models tab allows us to assign a symbol or schematic symbol to our part, as well as a footprint. To edit any of these, we can remove the symbol association by right-clicking, or click on this attach icon in the top right corner, the paperclip icon, and you can add a symbol, a footprint, or a piece-by-piece model. So if we had a different symbol that we wanted to use, we could scroll through here, find the symbol, and then click on the checkbox to assign that symbol. Let's go ahead and close this. And then if we wanted to change the footprint, same thing, click on the paperclip, select footprint, and then from this list, we would add whichever footprint we want to use. Now, because we downloaded this part from SamacSys, and the part happened to have both a schematic symbol and a footprint, these are already filled in for us, so we don't have to make any changes here. We'll worry about the manufacturer part number later, and as well as the mechanical data, we can leave that empty for now. Alright, to save this part, let's click Save, and it should be added into our library. If I go under My Workspace IC, I should now have this component. can even remove the search results just to make sure. Here it is, part number CDN demo 0001, and it has a description of MIC 5205. This is the 5-volt version. It's life cycles in development, and we're good to go. We can place this part simply by right-clicking and selecting place, placing it on our schematic, as many instances as we need. And if we're done, we can click right-click, done. All right, that is it for this video. In the next video, we're going to actually create a part from scratch, and using those parts that we create from scratch, we're actually going to start drawing the schematic that we're trying to accomplish in this video series. For the final outcome, we're not actually using any downloaded parts, so make sure that you find that OLB and the zip file that I mentioned earlier in the video and include them in your workspace so that you don't have to draw every single schematic symbol from scratch, and you can just reuse the symbols and the footprints that I created earlier. So I will see you in the next video. Thanks again for watching. If you have any comments or questions, please feel free to leave those below, and I will try to answer those as quickly as possible. Thanks for watching.